All right, here I want to show a trig sub example, and we can look at problem 4 for a trig substitution. And you can recognize it because the denominator looks like c squared minus b squared. And so if you set up a triangle, c squared is 9, so that would mean c is equal to 3. And then minus b squared, you can choose what other side you want. So 2x, because 2x times itself will be 4x squared. We'll call this angle theta. And then this piece is square root of 9 minus 4x squared based on the Pythagorean theorem. And so then if I look at theta, the adjacent side has the integrand in it, and then the hypotenuse is just a constant. So adjacent and hypotenuse is cosine, and I want to use secant because it puts it in the right order of being hypotenuse over adjacent, like this. If I don't see a 3 in the integrand, and so I'll just multiply both sides by a third. So I know that 1/3 secant theta is the integrand, and that's great. The other thing I would suggest is not using this substitution to find d theta. I would use a different substitution. I would say that sine of theta, sine is opposite over hypotenuse, so 2x over 3. So take the derivative of the left side, you get cosine theta d theta. Take the derivative of the right side, you get 2/3 dx right there. And I'm going to solve for dx. So dx is going to be 3 over 2 cosine theta d theta. So now I'm ready to substitute for the entire integrand. So we have from x equals 0, x equals 3 over 2. The integrand we said was 1/3 secant theta. And then the dx can be replaced with what we just solved for, 3 over 2 cosine theta d theta. This is really nice because the 3's can cancel out. And in fact, secant is 1 over cosine, and so secant and cosine can cancel out. So you just have a 1/2. So our antiderivative is 1/2 theta. At this point, we have our x bounds from x equals 0 to x equals 3 over 2. And so what we can do is use those to figure out the theta bounds. And so if I look at x equals 0, I'll do that in a different color up here at the top. If I look at x equals 0, then that implies that sine of theta equals 0, because 2 times 0 over 3. And sine of theta equals 0 when theta equals 0. The upper bound is x equals 3 over 2, which implies that sine of theta is 1, which implies that theta is 90 degrees, also known as pi over 2. So we just rewrote our bounds of integration in terms of theta. So we can evaluate 1/2 theta from 0 up to pi over 2. And that leads you to have, 1/2 times pi over 2 minus 0. In other words, the area under the curve is pi over 4. And there we go. So I'm happy to make more trig substitution videos, but that's all I have the time to make right now. And I just want to point out again that the other problems prior to this do not require trig substitution. Thanks for watching. Ask for more if you need them.